In this video, we're going to walk through an example of how to perform how to use the high-low method and the regression method to calculate our total costs, fixed cost, and variable costs. Here, we're given a company, excuse me, that we're given 12 months of activity. So the production in this case is hours, and the cost that we're looking at are total maintenance costs. Okay. So basically, a portion of the total maintenance cost is going to be driven by how many hours we're working on this maintenance. So we're going to use the high-low method to calculate the variable cost per maintenance hour, and then we'll calculate the total fixed cost. So the first step that we're going to do is find the highest cost and the lowest cost. It'll have the corresponding highest level of activity and corresponding lowest level of activity. So scanning real quick, it looks like June is going to be our lowest, and August is going to be our highest. So because our variable cost is cost per hour activity, we're going to do cost on top and hours of activity on the bottom. Okay, we're going to take our highest cost minus our lowest cost, and then we're going to take our highest hours minus our lowest hours. Then we're going to divide the two. So our costs divided by our hours of activity gives us a variable cost of $7.19. Now we know that total cost equals our fixed cost plus our variable cost times the number of units as represented by X. So now we know the total cost at both the highest and the lowest level activity. So we can pick either one. I'm going to pick highest, and then I'll show you that it's going to give you the same exact answer if we pick lowest. So our total cost in this case is 4470. It's going to be equal to our fixed cost, which is what we're solving for, plus our variable cost, which is $7.19, times our hours of activity, which is 520 hours in this case. All right. Then I'm going to rearrange the formula so that I get fixed cost equals 4470 minus 7.19 times 520. Okay. So our fixed cost equals 4470 minus 7.19 times 520. So you'll see that I linked it to the cell 7 where it had the variable cost instead of typing out 7.19. So that means that I'm not doing any intermediate rounding. So I'm not rounding to $7.19. I'm using the full extension here. So now I have a fixed cost of $730.95. So let's do the same thing, except let's pick our lowest cost or level of activity. So now it's going to be 2960 equals fixed cost plus 7.19 times variable cost of number of units, which is 310 in this case. Rearrange the formula, equals 2960 minus 7.19 times 310. Our fixed cost is going to be equal to, our 2960 minus 7.19 times 310. You'll see that I got the same exact numbers, whether I picked the highest or the lowest. Okay? So now I know that my fixed cost is $730.95 and my variable cost is $719. Now I can use this information to calculate my total cost at any level of activity. So here we're being asked to find the total maintenance cost if we have maintenance hours of 420 for 1 month. So we go back to our formula, which is total cost equals fixed cost plus variable cost times the number of units. So now our fixed cost we know is $730.95 plus our variable cost of $7.19, and we're trying to solve for 420 hours. All right, so it's going to be equal to the $730.95 plus the 719 times 420 hours. So this is our total cost for 420 hours. Okay? So now let's look at a regression model. So you'll see that I've already performed the regression analysis output. So I can show you what I did. Basically, you go to data, and now I can't find what I'm looking for, of course. Okay, well, you guys won't be asked to put together a regression model, but basically what it does is it looks at all the components of your X and Y axes. So you'll remember that your Y is your total cost, and your X is the level of production, in this case, hours of activity. The total cost is dependent on the hours of activity. So the hours of activity is the independent variable, and the maintenance cost is the dependent variable. So what the regression model does, it looks at all this information, and then it gives you this output. So we had 12 months that we looked at. There's 3 pieces of information that you should pay attention to: the R squared, the intercept coefficient, and the hours of activity coefficient. So what the R squared tells us is that 99.7% of the variability in the total maintenance cost is driven by the change in the hours of activity. So that means that the hours of activity is driving the change in the total cost. So the higher this percentage is, the more meaningful your results are. If this was 50%, then the results wouldn't be as meaningful, because only 50% of the change in total cost is driven by the hours of activity. So you might have to look at something else. Here, remember we talked about the X and the Y axes? Well, the fixed cost we mentioned intercept the axis. So this is going to be your fixed cost, $684.65 rounded. The hours of activity coefficient is going to be your variable cost, $7.29 rounded. So here we would look at our total cost is going to be equal to our fixed cost plus our variable cost times the number of hours, so 420 hours. So under the regression model, we get that our total cost is going to be total cost for 420 hours is $3,745.77. So you'll see that this is slightly different than the $37.50 here. And the reason for that is because under the high-low method, we're only looking at 2 data points, whereas the regression model, we're looking at all 12 data points. So it's more accurate. Okay? So hopefully this helps explain the difference between the high-low method and the regression method and how you would use these 2 methods.